Welcome back. So before the last lecture, we were talking about the fatty acids that have a double bond. We said that the configuration in which the double bond exists, this is where we ended. I was trying to draw this, that the configuration can be cis. This is a cis configuration where you have this group on the double bond and this group on the double bond on the same side. So this is a cis configuration. But you can also have this configuration where this group is opposite the other group. Okay, remember this is a methyl group. Okay, so this is a trans configuration. So fatty acids can exist if they have a double bond. The configuration that are possible is that you have a cis configuration and a trans configuration. So this is a trans configuration. Okay, but fatty acids that exist in living organisms, most of them exist as a cis configuration. That is not to say the trans do not exist, but most of them will exist as the cis configuration. Like we will learn about amino acids, that amino acids exist in the L form. We also learn that the sugars exist in the D form. Okay, so we are saying that the fatty acids that exist in living organisms, most of them exist in the cis form and not the trans form. Okay, so if we were to give the name of this organic acid, remember if you count there are 18 carbons. If there are 18, if it was saturated, if it didn't have a double bond, we'll call this as octadecanoic acid. Remember I'm saying if it was not saturated, but this is saturated. Okay, because it is saturated, we need to identify at what position does the double bond start. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, at carbon number 9, that's where the double bond starts. So we would say 9 octadeca. Then in between, take note, in between the A of deca and the N of noic, you put the position of a double bond. Okay, you put the position of a double bond. Sorry, we actually say this is a double bond, so it will be desanoic acid. I'm sorry, okay. So we replace the A with the E. Okay, it was decanoic acid. Okay, saturated will be called decanoic acid, but since it's not saturated, it has a double bond. The A is replaced with the E, so 9-octadecanoic acid. So we will have the cis, the first one. If I call this A and B, first one will be cis 9-deca, cis 9-octadecanoic acid. The B will be the trans 9-octadecanoic acid. Okay, so that's how we will name this particular fatty acid. Remember, we are looking at features of fatty acids. So the double bond is usually in the cis configuration and not in the trans configuration. Okay, right. This is one example. Okay, this is one example. Okay, this is called the oleic acid. This is called the oleic acid. Okay, remember in the previous lecture, which I said you need to correct. Okay, I had given stearic acid. I had given stearic acid as oleic acid. Please correct that mistake that I made in the previous lecture, I'm emphasizing, go back in the previous lecture, there is somewhere where I gave the example of oleic acid. Okay, it is steric acid and not oleic acid. That is the fatty acid that has 18 carbons and it is saturated. Okay, if we were to put this as okay, CH2, okay, right, this I gave as oleic acid. Please correct that mistake. This is the steric acid. Okay, this is the steric acid. I'm looking at the previous lecture. Okay, now that you have corrected that previous lecture, let's proceed on. I have given an example of saturated fatty acid which has only one double bond. But there are other examples that may have two double bonds. Okay, this has one double bond. That's the example we've just been looking at. But there can be another one. So 1, 2, 3. After 3 carbons, there can be a double bond. Okay, so carbon number 9, 10, 11, and carbon number 12, there may be a double bond here. Okay, so if that is the case, let's have a double bond here. Okay, this is carbon number 10, 11, this is 12, 13, and 14. Okay, so we can have hydrogen there. So you can have hydrogen there and hydrogen there. Sorry for that. Okay. Okay. And this is carbon number 12. Okay. So how would we name this IUPAC in the IUPAC manner? How would we name this fatty acid? This fatty acid, we are saying, what are we saying? We are saying it has 18 carbons. So if we wrote the name of a saturated, it would be decanoic acid. If it was saturated, please note, I'm saying if it is saturated. But this is not saturated. Okay? Because it's not saturated, we need to identify the positions of the double bond. The double bond is at carbon number 9. Okay? But there's another one at carbon number 12. So we'll say at position number 9 and at position number 12, there's a double bond. Okay? Now take note. How do you still maintain decanoic acid? No. So in between the A of deca and the N of noic acid, you introduce the prefix di, then E for double bond, di for the 2, E for the double bond, noic acid. So 9, 12 octa deca dioic acid. Are we okay? Yes, we are. Okay, 9, 12 octa deca I'll go through again. 9, 12 octa deca dinoic acid. Okay, so we can also say cis, since they are in the cis position. The double bonds are in the cis position. Okay, this is IUPAC nomenclature. The common name, okay, the common name of this compound will be called the alpha linoleic acid. Alpha linoleic acid. Okay. Now, it's common to, this is somehow cumbersome. We might choose to use the skeletal structure. If you use the skeletal structure, so we can say, starting from the carboxylic acid, which is our carboxylic acid group, so we can say 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. on the ninth one, there is a double bond. Okay, like that. So then we continue. That's 9, 10, 11, 12. At the 12th one, this is 9, 10, 11, 12. At the 12th one is a double bond. So we continue then 12, 13, 14, 15, 16, 17, 18. Okay, this is a skeletal structure. Skeletal structure. This is a skeletal structure. This is a displayed formula. This is a skeletal structure formula. Okay, of the same cis 9,12 octadecadioic acid or alpha-linoleic acid. Okay, but the other example, that's a second example for those that have a double bond. The other example that we might have is that at the carbon number 15 there may be a double bond. Okay, at carbon number 15 there may be a double bond. Okay, that being the case, then we can say we might have a double bond here. We can say we have a double bond here. Okay, we have the hydrogen there. Okay, remember it has to be in the cis. We have the hydrogen there. This is 15, 16, 17, and 18. Okay. Okay. I have not done justice to this. Let me draw it this way. This is it. 12, 15, 13, 14, and 15. Let me draw it this way. Okay, 15, 16, 17. Okay, like that. Okay, so we have a hydrogen there. Okay, it still has 18 carbons. Okay, it still has 18 carbon, except that it has the third double bond. So the third double bond is at position number 15. So we have one at position number 9, we have one at position number 12, we have another one at position number 15. So this is also cis 9, 12, 15, octa, deca. Again, remember this is coming from decanoic acid. Decanoic acid. Okay, so between A of the deca and the N of noic acid, you put the prefix tri. What is tri for? For 1, 2, 3. Tri is for 3. Then you put E for the double bond. E for alkenes. Remember alkenes? That's where the E is coming from. Then noic acid. Okay, so the name will be cis 9, 12, 15 octadecatrionoic acid. That's the IUPAC nomenclature. The common nomenclature, common name, this is called the linolenic acid. Linolenic acid. Remember, the previous one was linoleic acid. This is linolenic acid. Please distinguish the two. Okay, so if we were to put a double bond, remember this is 16, this is 15, 16, 17. Am I right? This is 15, 16, 17. No, not right. This is 9, 10, 11, 12, 13. This is 13. This is 14. And this is 15. So at 15 is a double bond here. This is 15, this is 16, 16, 17, and then 18. So that will be the skeletal structure of cis 9, 12, 15 octadecatrionic acid. Okay. Right. So these are examples of saturated fatty acids. Okay. The other one which is slightly different in terms of the position of a double bond, is arachidonic acid. Okay, arachidonic acid has at position number 5, there is a double bond. 5, and at position number 8 there is a double bond. At position number 11 there is a double bond. At position number 14 there is a double bond. In both cases it's 3. 9 plus 3, 12. 12 plus 3, 15. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. Okay, it has 20. Okay, remember 20, we said 20 is we said 20 is what? 20 we said is eicosanoic acid. If it is saturated, eicosanoic acid, that's what I told you. If it is saturated, the one we called arachidic acid. Okay, arachidic acid is eicosanoic acid. So since this has a double bond, 3 double bonds, so we are going to say between the A of Sa and the N of noic acid, we bring the prefix tetra. So eicosanoic tetra. Okay, what is a tetra for? 1, 2, 3, 4 double bonds. Okay, tetra. Then after we put the tetra, we need to put the E. The E is for the double bond. The tetra is for the 1, 2, 3, 4, the number of double bonds. The E is the suffix for double bonds, and then we put noic acid. So this will be called the eicosanoic acid. Okay, they are also in the cis position. So cis 5, 9, 11, 5, 8, 11, 14, eicosanoic acid. The common nomenclature, this is called the arachidonic acid. Arachidonic acid. Okay, these are the examples of unsaturated fatty acids. Okay, unsaturated fatty acids. Okay, if we look at the examples that I have given, the last 3 examples, what is common among them? What is common is that they all have more than one double bond. Okay, if you look at linoleic acid, it has 2 double bonds. If you look at linolenic acid, it has 3 double bonds. If you look at arachidonic acid, it has 4 double bonds. Okay, so these are considered to have many double bonds. So we say they are polyunsaturated fatty acids. Okay, so these are called polyunsaturated fatty acids. They are, in short, poly for P for poly, unsaturated, U for unsaturated, fatty, F for fatty, and A for acid. So sometimes called the PUFA. Okay, the PUFA. The PUFA are just the polyunsaturated fatty acid. What are the polyunsaturated fatty acids? These are fatty acids that have more than one double bond. Examples: linoleic acid, linolenic acid, arachidonic acid. These are unsaturated fatty acids. Right, remember we are still looking at the features of the fatty acids. We have looked at, just to remind you, that fatty acids can be saturated or fatty acids can be unsaturated, that fatty acids that are found in living organisms usually have even numbers. 12 lolic acid, 14 is what? Mithristic acid, 16 is palmitic acid, 16, 18 we said it's stearic acid. If they are unsaturated, they tend to have even numbers of carbon. Okay, then we have said that some may have unsaturated carbons, and those may have one double bond or more double bond. We have also said that they are, if they are unsaturated, the configuration is usually the cis configuration. Okay, right. Okay, now let's look at properties of these fatty acids in terms of the trends that we tend to see. Okay, the trends that we tend to see. Okay, so you tend to see melting point. Okay, you tend to see the melting points of fatty acids increasing with the increasing carbon chain. Okay, with the increasing of the carbon chain, it means that the melting point of a fatty acid will tend to increase. One would want to ask, why is it so? Okay, why is it that the fatty acids will tend to increase in terms of the melting points? Okay, obviously it is very clear. As you increase the number of carbons, the forces of interaction also increases. You agree with me? Yes. As you increase the number of carbons, it means that the sites where the van der Waals forces occur also will tend to increase. Okay? If you form the table, if you say you looked at which one? If you looked at lauric acid, for instance. Lauric acid. Okay? If you looked at lauric acid, what is the next one? Myristic acid. Myristic acid. Lauric acid, myristic acid, palmitic acid. Palmitic acid. This is 12 carbons, this is 14 carbons, this is 16 carbons, 18 carbons, stearic acid. Okay. Okay. I want to emphasize that this is a point that I need to keep on emphasizing, because I gave the wrong example in the previous slide. I named stearic acid as oleic acid. Okay? Oleic acid is that one that has a double bond, but it has 18 carbons. That one which is saturated is stearic acid. Okay? It's stearic acid. Right. If you have a melting point, do I have melting points somewhere? The melting point of lauric acid will be 44.2. Whereas that one of myristic acid, it will be 52. Okay, the one for palmitic acid, it will be 63.1. That one of stearic acid, it will be 69.6, and that one of arachidic acid, it will be 75, somewhere there. Okay. Arachidic acid. Okay, so what you see in terms of melting points, these are melting points. Okay, this is the number of carbons. Okay, this is the name of the fatty acid. Okay, you see that there is an increase in the melting points as you increase the number of carbons. For fatty acids that are saturated, these are all saturated fatty acids, and these are increasing the number of carbons. As you increase the number of carbons, the van der Waals forces, the van der Waals forces of interaction, van der Waals forces of interaction increases. When the van der Waals forces of interaction increases, it means that one molecule will be tightly held to another molecule on account of these forces that have increased. Okay? Remember the intermolecular forces of interaction that I mentioned in the first lecture. Okay? Molecules are held together by intermolecular forces of attraction. One of the weak forces, the weakest force that there is the van der Waals forces of interaction. And that is what keeps these fatty acids together. And now if the van der Waals forces of interaction increases, it means that the melting points of these fatty acids will also tend to increase, as long as the fatty acids are saturated. Okay? On the other hand, if you introduce unsaturation, okay, if you introduce unsaturation, let's say you have 16 carbon, but it is unsaturated. We call it palmitoleic acid. Okay. If you have 18 and you have 1 saturation, what did we call it? We called it oleic acid. Okay. If you have 18 and you have 2, we call it 2 double bond, we call it linoleic acid. Okay. If you have 18 and you have 3 double bond, we call it linolenic acid. Linolenic acid. Now, when you look at the double bonds of these fatty acids, okay, when you look at the double bond of these fatty acids, if you look at oleic acid, it will be oleic acid to be 4 minus 4 degrees Celsius. If you look at linoleic acid, it's minus 5 degrees Celsius. If you look at linoleic acid, it is minus 15. It's plus 15 actually, plus 4. Okay? If you further look at palmitoleic acid, did I include palmitoleic acid? Palmitoleic acid is 0 degrees. Okay, 0 degrees Celsius. Okay? Oleic acid to be in the range of 4, actually some books will give up to 10 degrees Celsius, somewhere there. Take note, what is it that you are observing? Is that, look, starting from here, this is carbon numbers. Carbon, the number of carbons are 16, like palmitic acid. Palmitic acid has 63 degrees Celsius. Okay, these are degrees Celsius, melting point. Okay, but go to the same number of carbons, but with 1 double bond, it goes to 0 degrees. It has reduced. Look at oleic acid. It has the same number of carbon as stearic acid. Stearic acid has melting point of 69. Oleic acid has 4 to 10 degrees Celsius. It has extensively dropped. Look at linoleic acid. Same number of carbon as stearic acid. Look at the melting point.